As part of collection framework, we started understanding what is a collection framework, why we are calling it as a collection framework, and what we are doing as part of collection framework by using collection framework. So we are dealing with collection of values, collection of objects simply. So that's why we are calling it as a collection of framework. So whenever we want to deal with more than one value, group of values, group of objects, then we have to utilize the collection framework libraries. Our collection framework predefined classes and interfaces and respective methods for respective operations. So as part of that, as part of hierarchy, first we taken the list interface, and from the list interface we taken ArrayList class, and we understand how ArrayList is working internally. Yes, as well as we started understanding taking examples with ArrayList for primitive values, string values, and as well as user defined values also. And we did all of the operations, all methods we understood, all predefined methods of an ArrayList we understood. Nothing but all basic operations are all of operations like adding the values, removing the values, iterating the values, printing the values, getting the values based on the index. So adding one array list to another array list, removing matching values. So like that, we taken couple of operations, couple of methods we have completed. So please practice all those things. That's most important because every day, every time when you are working on the real-time application, whenever you are implementing a business requirement, like whenever you are doing any kind of calculations or if you are applying any logic to or you are sending any notifications, whatever it is, when you are implementing the business logic, usually we will use regularly collection framework. So we will very rare case we will use arrays. Similarly, we will use array list, and sometimes we will go with hash set. Sometimes we will go with hash map. So that means most of the times we will use always collection framework classes and interfaces. And if you observe any frameworks also going further, you will see heavily internally they implemented their frameworks with the help of this collection framework only to return the multiple values, or wherever you go we will see mostly collection framework classes are available. So that much important it is. And to okay, and after that what I did yesterday is I given you assignments. Why I given is, yes, these are all very common and regular requirements. Okay, terminology may change, it's not like employee, but tomorrow when you are working for the Swiggy, so or maybe if you are working for any project of banking application, then you have to identify. So you have to, for example, out of 1,000 values you have to pick up one value, so based on a certain condition, or you have to find out sum of all the values, or you have to find out sum of I mean average of all the values, or maybe you have to find out some specific values based on a specific condition. So those to represent those kind of scenarios I given these assignments. And as well as why I given this right now is, so once you are done with this basic 10 to 15 uh, assignments, or maybe this 10 to 15 operations or these requirements you are done with respect to employee array list, so then you will understand stream API also very well. So to simplify these things what we are doing manually on top of collection framework by using regular for loops or for each loop, or maybe if conditions, and then comparisons, whatever you will do, right? So generally you will do so many things. Here it is, for example, yesterday, I mean, if you want to find out something, you will use if conditions. If you want to make condition evaluation, if conditions, and then to iterate the array list, you will use for loop or for each loop. Similarly, you will use some mappings, conversions, all these things, right? So those are all rectified in the Stream API. Those are all rectified in the Stream API in a functional programming point of view. So how it is rectified, what way it is rectified, and then the same operations whatever we represented here, so the same solution whatever the solutions we implemented without stream API and with the stream API, how we are implemented solutions, then you will realize the difference. So then you can easily understand how stream API is making our life is very easy. The reason is, nowadays everybody is using stream API in every application to do this kind of operations, not regular for loops and if conditions. So just go through it, and let's start with today linked list. class and what is a linked list and how it is working, and at what scenarios we have to go with the linked list rather than array list. I'll try to give you the difference. Okay, and coding wise, I'm telling you one more time, there is nothing will change. 90% is same method names, same kind of method names, same syntaxes, and same indexes, all these things. But internally, there is a lot of difference between array list and linked list. Let's try to understand. So architecture wise, there is a lot of change, but function coding wise, as a developer, what we are using, method names, all these things, 100%, more than 90%, all are common. Okay, so that's why our focus is more on the internally what is a linked list, how it is different from the array list and all. Not like programming, because we have done all the programming in the array list. I'll take one or two examples quickly, and same whatever you did or whatever the assignments are given with respect to array list, you can do same thing via linked list point of view also. Okay, so let's start linked list. What is a linked list and all? The first point here it is. Yes. So linked list is a data structure provided by collection framework. Okay, provided by collection framework, and you know that linked list is an implementation of list interface primarily. Okay, so one of the list interface implemented classes, linked list. Okay, and so then let's see the new point here. Linked list stores the values in a sequence in a sequence with the concept of nodes. So what is a node? I'll explain you. What is a node? I'll just explain you. So that's what. Here there is a new concept. Internally behavior is change. Internal way of representing data is different when comparing with array list and linked list. And yeah, and yeah. So every here node contains every node. I mean here node contains data and a reference or pointer reference or pointer to next next nodes or previous nodes of next or previous nodes. So I'll give you this all things what is happening and all. I'll try to explain. And generally we have different types of linked list. Okay, so one is single linked list, singly linked list or single linked list, whatever it is, and double linked list, and the circular linked list. So the linked list is categorized into multiple types of linked list in generally. So, but in Java, by default, in Java, so as part of linked list class, as part of linked list by default, they are creating double linked list. Okay. So that means whenever we are creating a linked list object in Java, linked list list equal to new linked list like that, internally it creates always doubly linked list, double linked list. Okay. So now the point is, what is a node? What I am saying, first of all, until this is okay. But the next point is what I am talking about node. Point number one. That is what new thing we have to understand now. And I said node contains data. So, and reference or pointer to the next or previous nodes. So what is the meaning of reference or pointer to the next nodes? Point, okay, that is what we have to understand. Then we will understand what is a singly linked list, what is a double linked list, and what is a circular linked list. So let's understand here it is. Okay. Okay. So here I said one point, linked list contains data in the form of nodes. So that means what is a node here it is. And I mentioned what is a node here it is. Node contains data as well as pointer to the next nodes. So that means I'll tell you first, this is the node. If I'm taking node is categorized into, okay. So with respect to single linked list point of view, two two categories. I'll mention that data here, pointer to next node, pointer to next node. This is node. This is the node. And sometimes the same node will have three more sections with respect to doubly linked list and circular linked list point of view. It will have data, okay, and pointer to next node. So here also we will have one more pointer. So I'll tell you what is the meaning of pointer. Pointer to previous node. Pointer to previous node. Okay. So that's what I'm trying to say with respect to node. Node contains data, but the point is, what is the data? What is the reference? So let's see now how linked list will form. For example, whenever you created a linked list, and whenever you are started adding the values. For example, what I will do is I created object linked list equal to new linked list. Okay, cool. And you know that we have to use generics in our collection framework point. So we have to use generics. Maybe assume I'm storing some integer values for time being. Okay, cool. Okay. So the moment I create a linked list, and whenever I am storing the values, list dot add. Okay. So I added value 100, value 100. So whenever it is an array list, whenever it is an array list, and whenever you added a value 100, what we understood yesterday. So this is all. So it will start creating a dynamic array, and it will start adding your values into index wise. So the moment you added first value, it will add it to 0 index. So it will add index like a 0 to, so index always starts from the 0, like that. Values are added first index, second index, third index, like that. Internally it is using a concept of an array concept it is using. And finally, whenever you are adding the first value, what will happen? It will add at first position, second value second position, third value third position, fourth value fourth position. I mean, like that, based on the array, internally it is using array, and inside an array, it is storing the values like based on the index point of view. But now, when it comes to the linked list point of view, whenever you made an add operation, you are adding the 100 value or any value, not only 100, any value. Now, what will happen here? It is immediately So with respect to single linked list, I'll tell you first, or double linked list, I'll tell first, and then we will see what is a single linked list. But by default, in Java, whenever we created an object, like for example, I created an object here. So internally it creates double linked list point of view. So let's see here. What it will do is, it will create immediately a node. Dynamically, what it will do is, so the moment, let's take code here. Okay, so the moment we created a linked list object, and whenever we are adding the value, what will happen here it is, so it will create a node. It will create a node. And what it will do is, it will create a node with two sections, three sections. One is a reference to the previous node. First part, middle part is data. Second part, third part is reference to the next node based on this. So now what is the meaning of, I'll tell you, reference to next node. So what is the data here? It is the value what you given is called as data. So the real value is 100. Okay. Now in this case, how many values available in the linked list? Only one value is available. Only one value is available. So that means only one node is existed in the linked list. Only one node is existed in the linked list. So here in this scenario, you don't have any nodes either right side or left side of this. That means you don't have more than one node. You have only one node. So that's why what will happen here it is. In this case, yeah. So in this case, what will happen here it is. It will consider as a empty. I mean this why, because you don't have any previous nodes. And for example, assume this is located in a memory point of view 1, 2, 3, 4. Okay, it's all memory point of view. Okay, so in the memory location 1, 2, 3 level, it is located this value or this node. Now what it will do is, the moment we added one more value, for example, let me add one more value, list dot add, I given 101 or any value 110, whatever it is. So the moment you added one more value, then what it will do is, it will create again a node. It will create again a node with the three sections. See guys, if you are decoding this word links, linked list, links means you know that, right? Generally how links looks. So you know the chains, right? Linking chains, links, how it will, you know that, right? So same kind of thing. So you know that, right? Links will be available like this. One link is linking with another link. I mean, so something like that. So it's all same kind of stuff here it is. So you're just making connectivity from with one link to another link. Generally, you will see that links, right, like this, and this is one link. And again, what you will do, iron links you will see, right? So you will connect this link to another one, and you will connect links to another one. I think your gold chains are all these things, right? So tomorrow, you know that whenever some damage is happened to one of the link in your gold chain, what you will do? You will remove that. Okay. And what you will do? You will make sure, I mean, you will not do, maybe you will go to that shop or whatever it is. You will connect one link to, and you will remove the damaged link, and you are making connected to the before link and next link, that previous link to that link and next link to of that link. You will make connectivity in between those two. Same, exactly same kind of concept. Okay. So that means what it is trying to do in this case is, the moment you added 110 value, yes, a node will be created internally, and the value is 110 data. Okay, cool. This is cool. So this is the real values, what you are storing. Now immediately what it will do is, it will start pointing to the previous node address. So what? It is pointing to the previous node address. So see the arrow mark. I'm just making here a reference of previous node address. For example, I'll give here that star 1, 2, 3, 4. So what is this star one? So in this case, what is this? A reference of previous address. A reference of previous node, not address, previous node. Reference of previous node. Okay. And immediately what will happen here, it is one more here. The first node will make a connectivity to this node. So then assume this is created in the memory location point of view. For example, hash 2233, something like that. Okay. Then what will happen? This value is presented. I mean, this will be referred here. It is star 2233. So what's happening here? A linking is happening. The linking is happening between one node to another node. One node to another node. So what is how it is happened with respect to a linked list, double linked list point of view. So this is double linked list by default. So a node contains its a value, and as well as it refers the next node, as well as it refers the previous node. Now in this case, this is the first node. This is the first node. So that's why here you don't have any previous node. So it will become null. It is a null value. So it is null means empty. I mean, there is no reference. Why? It's the first value. It is the first node. So it is the first node. But when it comes to the second node point of view, okay, as of now you added only two values. Then what has happened? For the second node perspective, you have the first node. You have one of the node. So that's why what it is taking, the reference of this first node is pointed, storing in the second node level. Now as well as what first node is doing, for the first node, immediately whenever second node came, it got value of first node. It got not value, the reference of the node. So this one. Okay. Now similarly, third value we added. For example, I added list dot add, and then I added value 120. Okay. So something like that. 120 I added. Now what will happen? Again, the moment third value added, one more node is created. In the sequence, that's what I'm trying to say. So now what will happen? Third value, third node. So what is the real value? We are storing 120. See here it is not using any array, guys. This is how they will ask in interviews. So, but when we are taking the coding perspective, so for example, if you see here, if I take the same example again, okay, so if you see here, coding wise, there is no difference. I already shown you so many times, but anyway. Why I am explaining this much internally here it is, that's what people will ask in interviews, what is the difference between ArrayList and LinkedList point of view. Then you should explain about all these things. Okay. So see here, the moment you added, or with respect to coding ways, you know that there is no difference. Only if you are changing the class name, but method wise add is same. You are doing add here also, and you are doing add in between this one also. Okay. So in this case, it's a linked list. So in this case, it's a linked list. So you are storing values. In this case, this is array list here, but here it is using arrays, but here it is using nodes. That is all. But coding wise same. You can't. That is what people will ask you. What is the difference between array list and linked list? Can you explain? So then you have to explain all this stuff. So now what will happen the moment third value is added? Same thing. Assume a memory location created for this again. So I given like 3344. Then again what it will do with respect to this, So this left hand side one will always point it to the previous node. So it will point it to the previous node. Sorry, it is pointed to the previous node address. It will point it to the previous node. Nothing but simply I will tell internally what it will do. It will maintain the reference. For example, I can mention 2233. Okay. And as well as what immediately this will do. Second node realizes like, okay, next node came. Then what second node will do is second node will point it to the next node, third node. Okay. The next node. And in this case, the memory location point of view, the reference will maintain the newly created node address called as 3344. So like that, now how many values you are having? Three values. So node 1, node 2, node 3. Now node 3 doesn't have any node 4. So in this case, again what will happen by default in this case is, here it is an empty, nothing but what will happen? This will become null. This will become null, here it is. This will become null. Why null? You don't have any node. You don't have any node right side. Assume you added one more node now. Then again what will happen? This null will be replaced with the next. So that null will be replaced with the next node. So that means, so now what will happen? For example, you added one more value. List dot add of, you added 130. Same story again. What will happen? Immediately a node is created and that node is having again three parts, and the real value is what you added, data is 130, and immediately what this previous node will understand, okay, my right hand side I got one more node, new node, let me delete this, let me point to new node. Like that it will point to the new node, it will make a pointer to the next node. So that means what it will do, it will remove this null and it will get the reference address of that node. So for example, this is created in 4455 point of view, then what it will do, it will store that reference here. And as well as what this will do, the new node now, it will point it to the previous node. So in this section, in this node, this left hand portion, so what it will do, it will have this value. Okay. So now this is how the next node connected to previous node connected to next. I mean, so this node connected to next node and this node connected to this previous node. So like that dynamically these things are happening. These things are happening. Now with respect to fourth node, what happened? Only four nodes you have as of now. So then the last node will become, I mean, in this case, it doesn't have any, it doesn't have any right side nodes. If anything is added again, then again this null will be removed and that new node memory address is referenced from this node like that. This is how internally it will start keep on adding the nodes and it will start making pointers like with respect to previous node and next node, previous node, next node references like that. Okay. So here again with respect to linked list, the first node will be called as head. So the first node will be called as head generally. So head, the terminology, first node will be called as head node. Last node will be called as tail node. Tail node. Okay. So when I can say as a tail node, it should be the last. So tail node point of view, with respect to double linked list point of view, this is double linked list. Okay. Whatever I'm explaining right now, it's a double linked list. What is a single and what is a circular? We will see that. So tail node. So that means what will happen, guys, in this case? Whenever you add it again, for example, again I added one more value list of 140 or something like that. So again I added new value called as list dot add of 140. So then what will happen again? The new node will be created. Okay. New node is created. That's fine. and as well as what it will do, the data point of view, it will take. So what value you stored 140, that's okay. And then what will happen guys in this case? This time new tail node you got it. New tail you got. Why? How can I say this is the tail now? Last node should be always tail. So then what it will do internally is the tail pointer. Now I am going to call this one as a tail node. Why? A new node came, that is the last node. Now in this case again what it will do? It will point to the previous node. So and assume this is created in the memory location of something like 5566 like that. So then what will happen? This null is removed, here it is. This null is removed, here it is. And what is the value it will maintain is 5566. Next node address, right? And in this case, it will maintain value of 4455. Previous node. Okay, and now this will become null. Why? Because it's a last node now. So that means in a double linked list, what you have to understand, guys, head previous, the point what you have to understand here, it is head node, okay, previous node reference is null. Okay. Similarly, tail node point of view, next node reference is null. Next node reference is null. So that is how you will by default an array list. So sorry, an array list will be, sorry, a linked list is going to be created internally, or linked list internally using a nodes concept. Here it is. Okay. So now again the points, let's take few more important points when comparing with array list also. One of the most important interview questions I'll cover here. So what it is, what I will do. Okay, this is doubly linked list, right? Let's give what is a single linked list in this case. Then I'll go with when you're doing insertion, what will happen at index level when you're doing remove operation, what will happen internally. So yesterday I explained you, right? So when you are doing the insertion at a specific index, then what will happen? Already in that index some of the values are there, but you are adding again specifically one more new value into specific index. Then already the presented old value, what it will got, what will happen, it will move to the next index, but in that index already one more value is there. So that means this adjustment will happen. So all indexes got adjusted. So that scenario we taken yesterday. For example, you have a value 100 here, 101 here. But all of a sudden, I came and I said, please put 999 in the zero index level. Then what will happen? 100 will come to first index, 100 will come to second index, 102 will come to third index. Like that, the shifting will happen. The shifting will happen. So now whenever you added 999 value, how many adjustments are happens? 10 adjustments are happens. Similarly, when you are doing the removing also, what will happen? So all the values are presented. The moment you deleted a value, what will happen? The moment you deleted d value, so it will start shifting. So it will start shifting. That means what is the meaning of shifting? F value or E value comes here and F value comes here, and like that all the values will come. So that means all indexes from 0 to last index wise, there will not be any index with empty. You will make sure all, I mean ArrayList will make sure values are presented in every index, okay, until the last value, until the last size of the array. So whenever you are making addition, it will start adjustments. Whenever you are making removing also, it will start, okay, making the adjustment. If you are adding at last, there is no adjustment. If you are removing last value, there is no adjustment. But I'm saying like when you are adding in the middle, when you are adding in the first index, then already first index level 100 is there. That's why we moved 100 here. Now whenever you added 999 at 100 level, index comma, so J index comma 999, like add 0 comma 999, then 100, what we have to do with 100? It's not overriding the 100 value. Okay, like that it will take care of adjustments, all these things and all. And when you are removing also, you are removing D. So that means this 0 1 2 3, this third index will not become empty or null. It will pick up previous next node values and it will keep in the third index, like that. It will make an index arrangement like that. But the same kind of insertion and deletion operations we are doing in the linked list, what will happen, I'll explain. So okay, so now what is a single linked list? I will give you high overview, and let's leave it. So if I taken this, it's very simple because now you know double linked list. Yeah. So this is called as double linked list, but when it comes to the single linked list, what will happen here? It is single linked list point of view. So this is the point, guys. Simple. Single linked list point of view, you will have a node where you will have two sections, that node data and pointer to next node. So that means in this case you don't have this section previous node reference. So it is always pointed to the next node. You don't have a reference or pointer of previous node point concept. Yeah, what happened? Accidental. Give me a moment. Something I clicked accidentally. Yeah. For time being, see linked list dot add 200. So linked list dot add. So if you see here index, for example, what is the meaning of index? If I given again index wise, my intention is please keep at first index point or second index, like that. Okay, let me add first values. I'll take 100, 110, 120. So 130, 140, like that. So you can add a number of values. So then this linked list will form internally. This double linked list. Yeah, sorry. Yeah. So single linked list point of view, the node will contain only next node reference, but there is no previous node reference. So that means what will happen in this scenario is a node will contain always next node reference. In this case, double linked list point of view, if you are having this node, whenever you have a reference of this node, from this node, you can identify what is the next node, okay, reference and its value. You can identify previous node data and its values also, because you have both of information, right hand side information, left hand side information, because of double linked list, and you are maintaining both side addresses. You are maintaining your right side address, left side address. Okay, you are having information of left hand side node information, right hand side node information. But when it comes to the single linked list point of view, it will always have only next node reference. So that means it will contain only next node reference. That's all. It doesn't have any backward direction, or like it is containing, it is storing the previous node reference. There is no concept. So this is what single linked list. Yeah. So this is what called as single linked list. So here you don't have any references, okay, or of previous nodes, So in this case, head is going to have previous node reference is null means no. Head will be there, but first of all, there is no previous node reference in this case. Only tail node point of view, next node reference will be null. Okay. So you don't have any previous node reference. This is what called as single linked list. Single linked list. Yeah, in Java by default, when we create a linked list, it will create always this one only because it's very easy. I mean, it's not easy. That means internally there is a performance factor point of view. It will give better results. That's why they taken that. How and all we will see that. Now, when it comes to the double linked list, sorry, circular linked list. So simple. It is little bit extended version of what double linked list only. So circular linked list is nothing but, let me take the this one. Okay. Okay. So in this case, circular linked list point of view, what will happen here it is this tail node is going to make a connectivity to head node. So now what happened? A circular is formed. If you observe here what's happened. So now tail node will have head node information and head node is going to have as a tail node information. For example, here I given as 1, 2, 3, 4. And here I given as tail node address 5566. So finally you made a circle in this case. What? Now tail node is maintaining head node information, head node is maintaining tail node information. So if you are just bending into this, I mean if you are observing this format, now what happened? So it formed a circle. It formed a circle. What? See, in this direction, it is started, right? First node onwards. Okay, it went like this and it came here and it is came here. Again, it is connected back here. So what happened? A circular is formed. So in this case, your tail node and head node, yeah. So in this case, if I taken these points again, you don't have any, I mean, you have head node and tail node. I'm not saying like that, but there is no null references with respect to previous node reference of head node and tail node point of view, next node references will not become any null. So because circular linked list. So that means you connected your head and tail and finally it formed a circle. So that's why it is calling as a circular linked list. It is calling as a circular linked list. Okay, so circular linked list is achieving by using double linked list only, not by using single linked list. Because single linked list will have only next node reference. It doesn't have any previous node references. Like that. And double linked list this one. And in Java by default, when you created linked list object, internally is it going to create single linked list or double linked list? In interviews, they will ask you. So when I create a linked list object, is it going to create option A double linked list, option B single linked list, option C circular, option D none, or whatever it is, or all of the above, something like that. So then you have to be specific. Okay, so this is how the difference between linked list and single linked list, double linked list, and circular linked list. Now let's come back to the operations wise. We will do some quick operations and then we will understand when you are doing insertion at a specific index level. Now you added in a sequence order. Now what I am saying is I want to add 140 at second index level. I am adding 140 in second index. That means 0, 1. That means after 110, I would like to add 140. That is what my intention. So so that means in this case already 100, 110, 120, 130, 140 like that you are added, right? Yeah. So now you are trying to add 140 at which position after 110. So that means in this position. So here you would like to add. Then how the things will happen. That is point number one. And sometimes I'll delete also. Assume all of sudden I deleted. Uh, okay. So in this case, I'm keeping this value like this, and I deleted 120. So that means what will happen? You are trying to delete 120. So simple. Now your gold chain formula you can apply. So what will happen? Same thing, right? You will just modify the value of double three double. I will come back. I will come back to that very clearly, point by point. Okay, let's do first of all a basic operations. So like comparing with ArrayList point of view. See 100, yeah, 120, yeah. So 120, 130, 140. Like that I can add the values. Now based on the index I can add means yes, I can add. Okay, link a list dot add 150. So here I will give index, for example 0, comma 150. So that means what is your intention? You are adding 150 at first index level, first position level. So now your head will become this one. So now what will happen? This will become a head node value. So how you can say that head node? Because you are adding at 0 index. Whatever is last, that is head node. So like that. Now linker list dot add last. So what is the meaning of add last? The value whatever you given, that is going to be added as a last node. So that means can I say like that will become as a tail node? Yes. Understand the methods. So linker list dot observe the method, add method we know, add last, add integer, index wise we know, directly adding a value. By default it will add at last. So this is specifically we are mentioning add at last. Stream operation we will understand later. Add all means what? Now you can imagine what is the meaning of add all. You can merge two linked list. You can add one array list to, sorry, one linked list to the another linked list. We did in the array list point of view. Same thing. I'm not doing here. You can try it. But internally, whenever you are making okay, linked list, then internally it will make this kind of arrangement in the memory point of view. Okay, and see here. Yeah, add all, add first, clear means removing all the values. Contains. So contains means what? Just checking a value existed or not. So I'll do contains. So I'm checking 300 value is available in the array. Okay. 600 value is available in the linked list or not. So it will give, if contains, it will give true, if otherwise false. So I'll print the result. So I'll print the result. Now see here. What you got? False. That means what? 600 is not there. If I given triple three, yes, true. So it is available. So same methods. See the point. What you have to understand. It looks like you are doing same functionality. Functionality wise same. Okay, but internally, so see the difference in the runtime level in the JVM memory level. 100% there is a difference. Okay, so that is how you have to understand the array list and linked list. And let me make. I'll not take all the things. Get, get first, get last, index of, in last index of object value, offer. Okay, leave it. Yeah, so these are all new methods with respect to LinkedList, not available in the ArrayList point of view. Peak means it will give first value. I'll show you the documentation. Okay, let's do one thing. First, let me take this size and then I'll call the peak method. Seven. And if I'm calling LinkedList dot peak, see what it is saying? It will remove peak means it will get the first element of the list. It will get the first element of the list. Returns null if the list is empty. So now let's see. Somewhat new to IntelliJ editor, but anyway, I'll try it. So what you got first value 150. Why 150? Because you added at zero index. So when you want to get direct value from the peak, first value, directly you can call peak method like that. Very simple things only you will see here. Okay, so wait notify all notify this you will understand in the threading point of view. So stream you will understand later. So convert it to array. So this, I mean, it's all stream operations. Okay, leave it. We will understand later. For each also I'll explain later. Consumer point of view. String to array. Yeah, converting to array. So if you want to convert to respect to array, you can convert. Sublist, you know that. Picking only sublist of values. Stream object. I will see that. Sorting also I'll explain. See, replace all, retain all. We understood in the array list also. So please do all these operations again in the linked list also, what we discussed so far in the array list point of view. So methods wise same, but internally it will maintain all the things with respect to what, guys? So it's all converting to array again. Remove first, remove last. Okay, so that is what remove first occurrence, remove last occurrence. If the value is repeated more than once, then what will happen? Remove object, remove index wise, remove value wise, remove last value. Automatically what it will do? It will remove the last value like that. So it will remove last value. Push pop, all these things are okay. So related to linked list methods. So from here you can identify what is the previous node, all these things point of view. Okay, so let's go back. So I'm telling you again one more time. When you want to, when you're attending the interviews, they will expect data structures knowledge, right? So the reality of data structures, I'll tell you, especially service based companies, like if you are taking our popular Indian based service companies, or maybe a lot of other even small product based companies also, they will not expect in and deep of data structures like what we will see graphs, okay, trees, all these things. They will expect more stronger knowledge, especially what you are by default having in the collection framework. Nothing but array list, linked list, vector, hash set, tree set. So how strong you are in this elements or in this basic data structures, they will verify. They will not go beyond that most of the times because they also knows that. Okay, because for example, if you take in my case, when I'm asking interviews, I will ask what is the array list, what is the linked list, and differences, how it will perform, which is a performance based, which one I have to choose. I will ask only around this collection framework classes and interfaces only. I will not go beyond that. Similarly, many companies, many people will do same thing. So be strong, especially what you are having with respect to our own collection framework. I mean, Java given by the collection framework. But if you want to get a more uh, high level or maybe okay product based companies, especially like Facebook, Instagram, sorry, this kind of companies, Meta company and Google or Apple, so any other companies like that, then Mintra. So then you have to go little bit in and deep data structures. Then you have to go a separate course called as data structures and algorithms. There they will explain all the algorithms also, how to retrieve values quickly. Okay, BFS algorithms, DFS algorithms, like that. They will explain a lot of other items. So that is a different stuff, different training. Okay. So what I will explain you right now is with respect to insertion and deletion, what will happen when it comes when comparing with the array list. Because from that we have to come up with a conclusion, array list is a better or array list is a better, or maybe linked list is better. Okay, so now this is the value you have, right? So now this is the linked list you have. Now what you are doing, add at second index level, you are trying to add a value called as 150. So this is what you are doing now. Now that means what is our point at index 2, second index 2 level. Okay, nothing but third value should be 150. That is what your intention. You are adding like this. Then if it is array list, if it is array list, if you are adding here, then how many adjustments are happening? For example, assume it is having 1000 values. 1000 values, for example. Then if I added it here, okay, in this level like this 150 value, if it is array list, if it is array list, then how many adjustments are happening, guys? Almost 1000 adjustments are happening. Like 150, okay, the value 101 will move to here, and whatever the old value available here, it will move 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 here, like that. All the adjustments will happen internally. So that means what you can understand here, it is huge number of adjustments are happening. Okay, huge number of adjustments are happening. So due to that, what will happen? So internally some process is running, means it will impact your performance, your application performance. But if it comes to the linked list point of view, now if you take in this scenario, what it will do is, it's again your gold chain scenario, gold chain theory. What it will do, it will take the array list, sorry, linked list. This is the default list what you created, add on. Now whenever you made add operation, what it will do is, okay. So what you said, index 2. So 0, 1, 2. So that means here it has to come. Then simply what it will do is, it will start adding the values. It will create a node here. It will start creating a node here. And node will contain again 3 sections. And what is the value created? What is the value you are adding? 150. And then some small adjustment is happening, like what's happening, what is the previous node address, 2233. So here it will observe, it will add, it will update 2233. It will add 2233. And what, so assume this is for this, a new memory location is created, like for example star 7788. Now what's happening? See, this time earlier it is contains this node address, right? But new node came into the picture. Now what I will do, I will remove this. I mean, internally what it will do, it will remove this node reference and it will update it as a 7788. It is updated as a 7788. Why? Because a new node came. So that's why now with respect to this node, next node is 7788. And with respect to new node, previous node is this one. Now similarly what will happen? It will maintain the next node address. So what is the next node address? 3344. And as well as what will happen in this node level, it will maintain previous node address. That means updation is happening. It is just updating. Okay, new person joined. Let me update his address like that. It is updating 7788. Previous node address is 7788. So that means what happened, guys, here. So now this is how your linked list is updated. Done. Now everything is cool, right? Now again, what's happened? Everything is cool. Second node, the new node is added here, right? You are added new node here. So then what happened? This it is having previous node is having its address, and this is having its address, and this is having its previous address, and this is having its previous address. Everything is correctly. If you see, everything is having its own previous addresses, next addresses point. So now my point here it is the moment you added, assume you are having 1000 values in this case also. In this case also you had 1000 nodes. 1000 values means 1000 nodes. But you added at almost first position. Almost first position. But how many adjustments are happened, guys? It's all single adjustment. So it's not disturbing like it's not making like okay, let's take this node value into this one and this memory is into this one, this memory. No, it's not doing anything. Simply what it is doing, it just making so it just making it created a new node. Sorry, it created a new node and just referred it make the addresses modifications from previous node and next node point of view and this node and this node. Finally, three nodes level, one small adjustment is happened. But it's not disturbing the rest of 900 nodes or 9 whatever it is 900 plus nodes. But if it is array list, you are seeing lot of adjustments. Similarly, deletion point of view also. For example, now you said like you mentioned as remove. Okay, I'll take like 1 comma. Yeah, remove. I give an index value 1. So in this case, index 1. Index 1. So that means value is your intention of what it is the value, whatever it is. But finally, it has to remove index 1. Now what will happen again with respect to same point of view? Okay, so now what will happen again? Yeah. So this is what our requirement now. Index value 110. Removing. Remove operation. So that means your ultimate goal is you have to remove this. Then what it will do? Same your chain theory, linking theory. So removing this. The moment removed, what will happen? So some adjustment has to be done in this case as well as in this case. What you will do? So now what's happening in this case is it will just try to make adjustment like this. And what is the adjustment? So now previous node is gone from the this point of view. Now previous node is 1 2 3 4. And in this case point of view, next node is not 2233. That is gone. That is what deleted. So now the next node is 7788. So now finally you are having a linked list. Now again you made a connectivity between this one and this one. So now see, this is having next node address and this is having its previous address, and 110 is gone. So now again in this case also, how many times the adjustments is happening is just like one single adjustment point of view, the operation is completed. But if it is array list, if it is array list, but if it is array list, what is going to happen? If you remove a third position, so D value, I mean, then you are having, for example, 100 values, 1000 values like this, then what will happen? All the values will be shifted to respective previous positions and all, like all 1000 values are going to be shifted. Like all these values will be disturbed. If you want to see that, okay. So if you see here, for example, I made this out of, yeah, array list, and then array list dot remove. Yeah, it's expecting my mind. So cool. It's reading my mind, man. Okay, so I'm just reviewing the value one. Value one means index one. So that means 0, 1. Now the moment, so generally what is the point in this case? What you will see? 100 comma 110 comma 120 comma 130 comma 140, right? So cool. Okay, 140. So in this case, again the index wise, this is 0 index, this is 1 index, this is 2 index, and this is 3 index, and this is 4 index, right? Now what I said, remove index number 1. Usually whenever you did this, what is our expectation? So whenever I'm done remove operation, okay, 0 is okay. So it should become empty. But in ArrayList that you will not have that such like that. It's not like you will keep again in the 2 index level 120, it's available as it is. No. Let's see. So what I'm trying to say here it is, once you have done that, internally what will happen here it is, the ArrayList will be, so 1 level 120 will come. 2, okay, 2 level 130 will come. 3 level 140 will come. So that means what's happened, the adjustments are happened, all left hand side values got adjusted. So right or wrong, see. Mhm. Yeah, if you see here, what happened? So same behavior, right? So it is 120 came into first position after removing this. So in the 120 place, 130 came. In the 130 place, 140 came. Similarly, if you have any other values, all or got adjusted. So that means now can you, so can you guess and tell me which is better for while insertion and deletion operations? Which is better means performance wise. Is it array list or linked list? Obviously, linked list. Okay, when you are having a huge amount of values, and whenever especially you are doing n number of again and again insertions and deletions on the data, so it's better to choose linked list instead of array list. Instead of array list. Okay, so that is how you have to represent all these explanation, or you have to give this kind of see, sometimes that's what guys they will ask you, What is the difference between a linked list? Can you explain how things will happen with respect to insertion and deletion? If you are going offline interview, explain them on a paper, or maybe definitely we'll have some white papers are over there. Definitely we'll have it. So then just explain them like this is what array, and if you are removing some value, then all these values will be adjusted to the previous indexes. But if you are doing like this, it's simple, just like a link adjustment you are doing. So adjustments are very less. So one adjustment, 1,000 adjustments. Definitely, it internally it is using a lot of resources. So that means it will impact the performance. So that's why linked list is better with respect to when you are doing more number of insertion and deletion operations on the data. So you have to take the data as part of linked list instead of array list. Like that you can explain them. And array list is using internally dynamic array, but arrays concept simply. But linked list is using nodes concept. A node will contain previous node reference, all these things. So if you are able to explain all these scenarios, so you have to be in a situation like this. Okay. So that is what about the linked list. So I'll do one thing. Mm, See, please prepare. I'll tell you guys some of the important FAQs as part of whatever is completed in the collection framework point of view. So they will ask these questions. Uh, Array list versus linked list. They will ask what is the difference between array list and linked list. So then you have to explain all these scenarios in theory point of view at least. So how array list will use internally arrays, linked list will use nodes, like that. Okay. And then which is better with respect to array list and versus linked list. That is also they will ask. Like which is better means which one I have to choose at what scenarios, like that. And list versus set. What is the difference between list versus set? Set we are not done as of now. So, that's why we will see that. So this question definitely they will ask. And third one is, yeah, one more is definitely this is also one of the important question, array list versus vector. Very small difference. Apart from there is no difference, but I'll give you the difference what it is. But to understand the difference, you should know threading. But we will complete threads later. Then again, you can recollect that point. Then you are good with that. Okay. So like that, you will. These are all popular questions. Whether you are fresher also, these things will be asked. Okay. So what I will do. See, this is what they are just saying. Like with respect to reading, ArrayList is better. With respect to insertion and deletion, that is what order of and time complexity, space complexity, something like that will happen. So they are saying like insertion or deletion point of view, it is very slow. So that means when you want to read the values, while reading, ArrayList is better. While reading, ArrayList is better. Okay. But when you are doing insertion and deletions point of view, more number of, it is very slow. So frequent, if you are reading data, ArrayList is better. But when it comes to linked list, reading is very slow, but insertion and deletion is very fast. Order of one adjustment only you are done. But here, a number of adjustments you are doing, like that. So that is how the key differences they will talk about. Okay, so that is what about the linked list and array list. And let's come back to the vector also. So very common linked list and vector. Only one small difference is there. What is that? I will tell you. So you have a implemented class called as vector, guys. From the list, you have a class called as vector list. interface, array list, linked list, and vector. So vector, what is a vector? Vector is a class implemented from list interface. Okay, list interface. And then is a class implemented from list interface. Now I'll give you a point. Let's see here. Vector is similar to array list only. That means with respect to internal functionality also. With respect to internal functionality also. But that means internally I can say like vector also using arrays concept only. Same 100% as it is. Okay, the internal behavior point of view, vector also using arrays concept only internally. So that's why I said it is similar to array list functionality internally also. But then why they created a new class again vector, or why they given vector and array list when everything is same? Then why they given as special is, so only one small difference between array list and vector is vector is vector is class implemented as vector implemented as by default thread safety, by default thread safety are synchronized. Okay, only difference is this is the difference. That means the contradiction point to this with respect to array list is array list implemented, okay, array list is by default not thread safety or not synchronized. This is the only difference between array list and vector you will identify. And but internal behavior point of view, arrays only same thing. But now the question is, what is the meaning of thread safety? Generally, to understand this, actually we have to complete threads concept. We are not completed it, so unfortunately, but I'll complete it later. But I'll give you overview. What is the threads and all? I'll give you. So let me note down that. Okay, so completion point of view, I'll do that. But I'll give you just overview. Let's see here it is. What is the high level point of? What is a thread safe? What is not thread safe? I'll try to just give you a small overview. That's all. See, generally, when you are working in any operating system, Linux, Windows, or whatever it is, so whenever you are running your execution, your what your Java programs, .NET programs, Python programs, whatever it is, whatever you are running in your computer, generally what will happen? You will know that some processes will execute. If you see here, task manager wise, you can see lot of processors here. I think somewhere else. See, these are all processes, app history, or somewhere else you can see processes also. Yeah, this is what process ID. See here, PID means process ID. These are all processes. So whenever you are opening Chrome browser, these many processes are running in the backend. Okay. So see, lot of processes are happening in your operating system point of view. What is happening? So many things are happening. These are all comes under processes. PID, process ID, process name, something like that. So if you are stopping off of all this process, then your system will not work properly. So you should not touch this generally. So that means all in the back end, what's happening? Processes are running. That's why you are able to see this paint diagram, all these things and everything. You are able to work on this system. Okay, lot of processes happening. How many thousands of processes are happening? So these are all processes. Okay. Similarly, a subcomponent available for the process called as threads threads concept. Okay, I'll explain at threads level what is a thread, what is and all. So process is the max, and inside max you will have threads again. So in a single process, you will have again threads, multiple threads. So with when it comes to this vector point of view, what I can say is, for example, you created vector object, okay, and you created array list object. Uh, it's better to complete threads first before. Okay, anyway, it's a small point. It will not impact. But once you are done with the threads concept, then you will, if you reading this point like vector is a thread safe, array list is not a thread safe, then you will understand all the concept. So assume this is a vector. Now in this case, what will happen here it is, when it comes to thread safe, so which is a thread safe? This is a thread safe. And this is not a thread safe. By default, not thread safe. It's not implemented like that. So there is no threading in. So what will happen here it is, on high level, I'll explain you guys. Assume now 5 threads are running in my application, 5 threads. So 5 threads are running means what will happen is, at a time there is a possibility of, on the single array list object, in the memory only single array list object is available. How many? Only one object is available. At a time all 5 threads, okay, will come and access or perform operations on this array list. Now for example, one thread is doing remove operation, one thread is doing add operation, like that all will happen at a time. So that means there is no control on this array list object. Any thread can enter can access this array list, and it will perform remove operations, add operations, whatever they want to do, they can do it. There is no control on array list object. By default, operating system or whatever Java JVM is not controlling, or because array list is not a thread safe. That means any thread can access at any point of time, okay, parallelly or like that, it can access and it will perform operations on the array list. So that means what will happen in this case is, sometimes you will see data inconsistency. You will not see the data consistency, data inconsistency. So that means at the end of some method execution, you are not guarantee what is being happened on the array list or which thread is doing what and all. So you don't have any control on the thread execution. Simply I can say like you don't have any thread execution control. But when it comes to vector point of view, for example, again, 5 threads are there. Okay. 5 threads are there. So what will happen in this case is, vector is a thread safe. The moment thread safe is, you implemented this class as a thread safe means, when 5 threads are trying to access vector, at a time 5 threads cannot perform operation on the vector. What it will do is, internally there is a thread manager concept will available. Okay, thread manager. So this all you will understand in the threads concept. I'll explain that later. Multi-threading. So that is what multi-threads, multi-threading, multi-threads. 5 threads means multi-threading. If you have only one thread, there is no problem. When you have more threads, then what will happen here? It is the thread manager will make sure protecting this vector object, like it will allow all the threads, but it will make sure one at a time, one at a time, one at a time. So thread one entered and completed some task, and then it will allow to thread two. So then thread 2 completed, then based on the priority, it will allow thread 4 or thread 5. But one at a time, it will make sure this object being accessed. So this behavior by default comes when you are created the vector object in our, okay, in your application. So let's see here, new. See, apart from that, 100% concept is array list only. Even internal behavior also, guys. Same arrays that removes, adjustments, whatever it is. That's why I'm not touching again all these things. Just I will show you. So this is what by default they implemented as a threading. Java language team itself, they implemented like that. Okay. I should not use same class name. Okay, vector. So I'll create string So vector dot add values b c. I mean, you can add values. See here, I'm just adding the values. So that means what's happening in this case? It's all same thing. But internally, this class, while the Java team implemented this class, the moment you created this object at any point of time, what will happen is whenever you are involving this object into multi-threading, okay, we are involving into multi-threads, and whenever multiple threads are trying to access, it will protect, it will make sure one thread is going to be accessing that object at a time. Like that, it will make sure. That is what comes under the thread set. So that behavior by default comes with the vector. By default not comes with the array list. Can we make sure array list as a thread safe means? Yes, we can do that. For that, as a developer, we have to write the logic by using our multi-threading knowledge, or some predefined methods also there in the collection framework itself. So like synchronize a list. Now, can you make array list as a, in interviews they will ask you, can we make array list as a say thread safe or not? By default, not, right? For example, if I take an array list, yeah, so now I created array list object, right? By default, array list is not a thread safe. Can we make array list as a thread safe means? You can do that. So one thing is you can write multi-threading logic or whatever it is by on top of this object. That is one thing. Or else by default, if you want to make sure, you have a predefined method called as synchronized collections. Something is, yeah, collections dot synchronized collection. If you see here, synchronized list. So that means if you are passing array list, so if you observe here, synchronize list, what it is giving, if you are passing existing array list, it will give you new list to you. So what is the existing list? Array list. Pass it. Then yes, now this array list is synchronized. Nothing but now this array list you made as a thread safe. But externally you are doing. As a developer, you are writing the logic. Otherwise, by default, not thread safe. But vector by default thread safe. That is the only difference between array list and vector point of view. So apart from that, coding wise, internal memory management point of view, addition, insertion values, it is as it is like array list. Okay, so that is all about vector class also. So remaining operations and all like add, remove, all these things, please take care guys. Okay, I'm telling you one more time, please at least practice one or two examples. Don't come to like a conclusion. Dilip sir said same thing, but at least you, from your side, please practice all these examples one time. Is empty, whether it is empty, contains, remove all. See, same 100% same methods available in the array list also. Okay, so just take care of it. With this, we are done with list interface. So tomorrow I'm going to start with set interface. Okay, and set interface also we will see very quickly, and then yeah, we will start with set interface tomorrow, and we will see hash set, tree set. What is the difference between hash set and tree set? All these details we will see in tomorrow's session. What is the difference between list and set? We will discuss a points also.